we want to find the average rate of change of a function. And what that means, we have a function, however it is, and we take any 2 points on the function. The slope of the line connecting those 2 points is the average rate of change over this portion of the domain. So you can see this function gets larger, and then it gets a lot smaller, and then it gets larger again. So the average rate of change isn't very much. It doesn't change very much from here to here. Vertically, it doesn't change very much. So the formula for this, I'm going to use f because that's our standard function notation, is the change in y over the change in x, or in other words, f of y2, f of x2 minus f of x1 all over x2 minus x1. This is also called y2 minus y1 over x2 minus x1, which is the formula for slope of a line. And it doesn't matter which point goes first. It doesn't matter which point we call x1, y1, and which point we call x2, y2, as long as we are consistent and do the same in both the numerator and the denominator. So the first thing I want to do, if this is x1 and this is x2, I want to evaluate g at those values. So g of 7 is negative 3 times 7 plus 7, which is negative 21 plus 7, negative 14. And g of 9 is negative 3 times 9 plus 7, which is negative 27 plus 7, that's negative 20. Now, substituting these values in for the numerator here of my formula, f of x2 is negative 20 minus f of x1, which is negative 14. And all of that over the change in x, 9 minus 7. Now that is negative 20 plus 14, that is negative 6. And 9 minus 7 is 2, that is negative 3, is the average rate of change between 7 and 9 for this function. And look, that's the same thing as the slope. Lines have a constant rate of change, so for any linear function, our average rate of change should be the slope.